Hello everyone, Andrew here again with another presentation for you. This time it's natural science, and we're going to look at physical changes and changes of state. So let's get started. The first thing we need to answer is, what is a physical change? Well, they can be changes to the size, shape, color, or state of matter of a substance. And physical changes do not produce new substances. In other words, after a physical change, matter is still made up of the same substance. So we're only changing something physically, like the size, shape, color, or state of matter, but nothing new is being created. So here's a few good examples of physical changes. In the top left corner, we have a broken glass, right? The drinking glass has been broken, and it's now in several pieces. But this has only changed the size and the shape of the glass. It's still a glass, right? It's just in several different pieces now. So that would be a physical change. And in the top right corner, we have somebody chopping wood. And that's another physical change, because just like the glass, we're only changing the size and the shape of the wood. It's still wood, but just in two pieces instead of one. That's a physical change. And on the bottom, we have examples of water changing its state of matter. And any changes in the state of matter, those being solid, liquid, and gas, those are going to be physical changes as well. So, and we do these changes in state of matter. These are caused by either heating or cooling, right? Making something hotter or making something colder. And by doing that, we can change the state of matter. We can take a solid and make it into a liquid, or a liquid and turn it into a gas, something like that. But the most important thing is to remember that no new substance is being created. It's the same substance, but just in a different state of matter, either solid, liquid, or gas. So we've seen that we can cause these physical changes by breaking something, changing its size or shape, like the glass or the wood that we just saw. But we can also change its state of matter, and like solid, liquid, or gas. And most of these changes are caused by either heating or cooling a substance, either making a substance hotter or making a substance colder. And that's what we're going to focus on for the rest of the presentation, is changes, physical changes, and the changes in the state of matter by either heating something or cooling something. So let's take a look. We're going to start with physical changes through heating, making something hotter, in other words. So some physical changes can be caused by heating a substance, or raising its temperature by adding heat to it. And the examples that we will see include melting, vaporization, well, two types of vaporization. We have evaporation and boiling. And the third example we'll see is sublimation. So let's take a look. The first example we're going to see is melting. And so melting happens when a solid turns into a liquid, right? If we have a substance that's in a solid state of matter, we can add enough heat to it that it will melt and turn into a liquid. And a few examples along the bottom here, we have ice cream melting. So when ice cream is frozen, when it's right out of the freezer, it's solid. But if we add enough heat to it, if it sits out in the heat long enough, then it will melt. And that just means it's changed into a liquid. It's changed its state of matter because of the heat that was added to it. This can also happen with chocolate. If you leave a chocolate bar out in the heat for too long, or add heat to it, then it will melt. It will go from a solid to a liquid. And of course, we have the Wicked Witch of the West from The Wizard of Oz. Spoiler alert, she does get melted at the end, so sometimes even witches can go from a solid to a liquid. So the next physical change that we're going to see is called vaporization. And vaporization occurs when a liquid turns into a gas. And there are two types of vaporization that we'll see. These include evaporation and boiling. So we'll take a look at those in more detail. But if we look at so the next physical change that we're going to look at is vaporization. And vaporization occurs when a liquid turns into a gas. This is done through heat. So if we have a substance that is in a liquid state and add enough heat to it, it will eventually turn into a gas, or its gaseous state. So, and if we can pick apart this word vapor. So the first two syllables in vaporization are vapor. And that word vapor means the gaseous state of any substance. So anytime something is in its gaseous state, we can call that vapor. So the word itself tells us that the end product of this process will be a gas, that we're adding heat to something to change it into a gas or into vapor. And there are two types of vaporization that we're going to see. And these include evaporation and boiling. So we'll take a look at those in more detail. Also, along the bottom here, I've put little diagrams for each physical change that we'll see. Just the change that's happening. Like in this example, we have a liquid going to a gas. And the red arrow in between means that heat is being added, that we're getting hotter. So anytime you have a liquid and it gets hotter, it will eventually turn into a gas or vapor. So, and I've put those diagrams along for each change that you'll see. We'll eventually see blue arrows when we're talking about cooling, but for now, the red arrow means we're getting hotter. Liquid getting hotter turns into a gas, like that. So the first type of vaporization we have is called evaporation. And this type of vaporization happens slowly. It happens gradually or little by little. And it happens so slowly that the liquid does not boil. So a good example of this is when clothes dry on a clothesline. So we have wet clothes. They have liquid water on them, right? Water in its liquid state. And we hang them up outside. And the idea is the heat from the sun will heat up the water that's on the clothes in its liquid form slowly. It will slowly change into a gas. It will change into vapor or its gaseous state. And so this happens little by little. And the idea is that eventually the heat from the sun will change all of the liquid water into gaseous water. And when the water is changed into a gas, it's no longer on the clothes. And so once all the liquid water has been heated and changed into a gaseous water or vapor, then the clothes are dry. So that's kind of the idea behind evaporation. Another good example of evaporation is this diagram here. We see this in the water cycle. So we have liquid water in the ocean, obviously, and the heat from the sun will slowly heat that water up and evaporate some of it. So this liquid water will get so hot that it will change into vapor, its gaseous state, and eventually be part of just like the air around it, the atmosphere, or all the different gases like oxygen and nitrogen in the air. This water vapor will eventually be a part of that. And it happens slowly, little by little, and we can see this in the water cycle. But this is another example of evaporation. So the other type of vaporization we have is boiling. And this type of vaporization happens fast. And it happens when a liquid reaches a certain temperature. The best example of this is when water boils. So if we have water in its liquid form and we add enough heat to it to where it reaches a certain temperature, then it will change its state of matter into a gas or into a vapor. And we can call this water vapor steam. So vapor is the gaseous state of any substance, and the gaseous state of water we can call steam. So all of this, what looks like smoke coming off the pot, is actually steam. That is the water vapor that has been created because so much heat has been added to the liquid water that it's changed into a gas, or in this case, steam. So that's boiling. Another type of physical change that is done through heating is called sublimation. And sublimation happens when a solid turns into a gas. And the solid substance actually skips the liquid state and moves directly into the gaseous state. So before, we've seen solid to liquid and then liquid to gas. But in sublimation, it's different because the liquid state is skipped over completely, and we just go from solid to gas. It never turns into a liquid, and that's the difference with sublimation. So the best example of sublimation is going to be dry ice. And you might have seen dry ice before in videos or maybe even in person. But what it is carbon dioxide in a solid form. So, like we breathe in oxygen and release carbon dioxide, right, in respiration. That's in the gaseous form. But when it's in its solid form, it looks like this, dry ice. And when you take dry ice out of where it's being stored, very cold, into like just a room with a normal temperature, then it gives off this gas, and it doesn't have to go to a liquid. Like it just skips over that completely, and it goes from a solid to a gas with never being a liquid. So without getting into too many details, this is just a good example of sublimation that you can see with your own eyes. We have this solid carbon dioxide, the heat from however you want to heat it up, even just being in a room, a hot room, will make it change its state and go from a solid to a gas while never being a liquid. So that's a good example of sublimation. So now that we've looked at physical changes through heating, let's shift our focus to physical changes through cooling, or things getting colder. So other physical changes are caused by cooling or lowering the temperature of a substance. And so some examples of this that we're going to see are condensation, solidification, and reverse sublimation. So let's take a look. The first example we'll see is condensation. And condensation occurs when a gas turns into a liquid. For example, when vapor from a hot shower steams up the bathroom mirror. Okay? So this time we're starting with the gas, with the vapor, right? In this case, if it's water, we're talking about steam, right? Remember the steam coming off the pot of boiling water? So that's where we're starting. So, for example, you take a hot shower and there's lots of steam, water vapor coming off the hot water. And so eventually that is going to, settle in the air in the bathroom, and when it lands on the bathroom mirror, it cools it down. It takes away some of the heat. And so that water vapor that was super hot coming out of the shower, it cools on the mirror and changes its state into a liquid. And then that's why the mirror looks wet, because the gas, the water vapor, has settled or stayed on the mirror and changed its state into a liquid. It's still water, but now it's just liquid water. So we take the gas, cool it down, and it becomes a liquid, and that's known as condensation. So another example of physical changes through cooling is solidification. And this occurs when a liquid turns into a solid. And just like that word vaporization, we have a nice clue in this word. The first, we can actually take out the word solid out of solidification. So just like with vaporization, the end product was vapor, we know with solidification, the end product, or what we end up with, is going to be a solid. So it kind of gives you a hint in the word about what it means. Solidification means going into a solid. And a good example of this is when water becomes ice cubes in the freezer. So we have liquid water, right? And if we cool it down in the freezer, lower its temperature enough, it will eventually change into a solid. So that is known as solidification. The last example of a physical change that is done through cooling is reverse sublimation. So reverse sublimation happens when a gas turns into a solid. So just like with sublimation, the liquid state is skipped, is passed over. The substance never turns into a liquid. In sublimation, it goes from solid to gas with no liquid step in between. But in reverse sublimation, it's just reversed. We go from a gas to a solid, and it never goes into a liquid. And so a good example of this is when frost forms on a car. So we could have some water vapor in the air, and this is the gas that we're talking about, is water vapor. And sometimes the air outside will get so cold that this gas, this water vapor, will settle on objects and turn into a solid. And it's not called freezing, because freezing is, as we've seen, is a liquid into a solid, or solidification, right? So it's not solidifying because it's never a liquid, but it's going from a gas to a solid. So this gas will settle on usually your car or some plants or like buildings. Could be any surface, but you can really see it on cars. And this gas will settle on that surface, and the air around it in the atmosphere is so cold that it makes it change its state into a solid. It's never a liquid, just gas to solid, and that's known as reverse sublimation. Here we have a diagram that is very similar to the one in your textbook, but it is basically a review of everything we've just gone over. It can be a little confusing when you first look at it, but if you just break it down into smaller chunks, just individual little pieces, it's actually quite helpful. So all the red arrows are going to be heating or getting hotter, and all the blue arrows are cooling or getting colder. So you just have to follow the box one by one. So if we start with solid and just go up and to the right, we eventually get to liquid, and that's known as melting, as you can see above that first arrow. And if we look at liquid and go to the right, up and to the right, we get to a gas. And remember, that's called vaporization. And also, so finally, if we go back to solid, skip over liquid and go straight to gas, that was sublimation. And then for cooling, if we start with a gas and get a little bit colder and get to a liquid, that was known as condensation. So now looking at liquid, if we get even colder, we will eventually get to a solid, and that's known as solidification. And going back to gas, if we go from gas straight to solid with skipping over liquid, remember that was reverse sublimation. So this is just a handy little diagram, a little tool that you can use to quickly review these different physical changes through heating or cooling. Here's a little review of everything that we've just gone over in this presentation. So I've put here all the different changes that we went over. Solid to liquid, liquid to gas, solid to gas, and so on. So try to answer all of these questions without having to look. Just memorizing them and knowing. Okay, solid to liquid, oh right, that's melting. Okay, let's see, liquid to gas, right, vaporization. And then the two types of those, fast and slow. So just try to do this review without having to go back and look. Well, that's the end of the presentation. I hope you enjoyed it and learned something about physical changes and changing states of matter through heating or cooling. So until next time, bye-bye.